Hi, this is Dan Scantland, and I was going to run through my solution of problem 2 on homework 3, I guess. So, this problem is based on a block sitting on a wedge, and both are sliding both against each other and across the ground. Uh, the position vector for the block is it's sliding down the hill, so cosine and minus sine times its displacement on the greater block minus the displacement performed by the wedge. And the wedge is just the displacement of the wedge. So the velocity is just the time derivative of all the positions. The none of the angles are dependent. None of the velocities are. None of the angles are changing, and therefore, it's only dependent on the changing of the position. Acceleration is the same way, so you just take the second derivative, and so you can see that here is my position vector, and here is my acceleration vectors for both of those. So the only acting force on each of the two blocks is its own gravity. The gravity of the smaller block working on the ramp is not accounted for here because that is a constraint on the block. It is not a force acting upon it. So we took the derivative in the direction of the block of the movement of the block, and and in the direction of the moving ramp. And so you get cosine theta n1 minus sine theta n2 minus n1, 0 minus n1. Here's D'Alembert's formula. And so first we do it in the direction of the block. So I'm not going to read all of this, but you do the acting force minus the acceleration dot the direction equals 0. Luckily, one term disappears because of this 0 vector up here. And so you get the relationship that the movement of the block is equal to, of the ramp is equal to the movement of the block by cosine theta, which makes sense. And that this all assumes that we're starting looking at when they first start sliding against each other. Obviously, you could offset this if they didn't start together. Moving to my next page. Then we looked in the ramp direction, which I've mislabeled here, but I will fix that before I turn it in. Minus, you can see this. Oops. I meant to cross off the last page. This is not correct. Disregard. So here's the direction of the block. You end up with the relationship that xb movement, the acceleration of the block is equal to acceleration of the ramp plus g sine alpha, which makes sense. The block needs to accelerate more than the ramp because the ramp is only going in one direction, whereas the block is going in two. So you repeat that in the other direction, and you end up with the acceleration of the ramp being this value and the acceleration of the block being this value. Hope this helps. I know it's late, so probably not, but hope everybody had a successful time working on this as I did. Bye.